My name na Ayodich from GU Dev, and the person wey dey with me na Chidera. E don be 184 days since we do the quad phase collision, and this na drone school.
You know, welcome to Drone School Drone Piloting Skills 101. Now the first video where we did do for our drone school series them. The first thing where any good pilot need to know now to understand his or her machine well, both inside and outside. Drones and multi-rotor aircrafts now one of the better things for modern technology with STEM disciplines. Don't make us sabi.
In fact, if you want build and fly drones as correct experts, you supposed to be engineer, because to produce drone wey go perform well, you suppose sabi design the way the drone go take power itself, so the iron things together, use meter for your motor and thrust, do calibration for the quad, customize how the programming go be, and all the things. So now just the beginning, but make una no worry, plenty community of experts for all these things them dey wey go help una understand them well and to sabi do am wella. We go give una the mathematics, physics, electrical, mechanical, and software engineering you go need to understand and master how to build drone well.
As we dey go, we go introduce you now to some of the great people wey contribute to the open source community wey get plenty tutorials and knowledge.
Contributors like Kabob FPV, Joshua Badwell, Oscar Liang, Mini Quad Test Bench, Blue Falcon, Flight Test, Rotor Riot, Electro Boom, AVE.
Make we start. No they produce trust, now props they produce them. The flight controller go send PWM signal to digital signals to electric speed controller wey be ESC. The PWM duty say they control how the MOSFETs go use on and off. Now that on and off they control the polarity of the magnet where they inside the motor.
The speed wey be say the magnet they use change polarity. Now waiting they control the speed where the motor will use rotate. As the rotor they rotate, it rotates the props wey go drag the air, and it go draw as many current wey it needs to match the rotational speed targets.
The current wey they draw must pass through the ESC, or less if the motor draw too much current, the ESC go burn.
The speed wey be say the motor they use spin, now waiting go spin the propeller. The more drag wey the propeller go encounter, the more current wey the motor go draw to achieve the speed wey you need to rotate, as defined by MOSFET switching. The speed wey the props they use rotate and pitch of the prop they determine the amount of thrust wey it go produce.
Make we touchlight wetin them they call forces and structural dynamics where they affect how the drone they take fly. Before we talk about how the drone they take use thrust, make we first talk about rotational force and torque where the motor where the spin they produce.
Newton's third law wey talk say every action gets an opposite and equal reaction.
The motor where they spin they produce rotational force, but the force they opposite to wetin them mount arm on top.
So as we dey apply the force wey they spin on the prop shaft for one direction, opposite force they apply for the drone frame.
To make the drone easy to fly, two props go rotate in one direction while two go rotate for another direction. As long say the total force where one rotation they produce for one direction now the same force with the force where the other rotation for another direction they produce, the quad go balance well straight for air, meaning say it no go bend or we all one side.
But if the force where they rotate the two props for one direction strong past the force where they rotate the two props for another direction, it go make the drone yaw for the direction of the force where weak pass.
Here they see say the motor where they rotate for counterclockwise direction they produce more torque than the motor where they rotate clockwise. Therefore, the counterclockwise motor they produce opposite clockwise torque, and they make the drone yaw for clockwise rotation.
For waiting them they call Mo2 transmitter, now the left and right movement of the left stick where they control the yaw.
When you move the left stick left and right, you go notice say the throttle for two motors they spin in one direction go increase, while the two motors where they spin in the opposite direction go reduce.
Now waiting they make the drone go flat, yaw, so it go stable for air while it no go fall. Flat yaw now when the drone rotates for Z axis, or waiting them they call vertical axis, where it go dey comot from on top the drone.
Make we talk about thrust now. Thrust na the force wey dey push the drone mass upwards against gravity to make am fly.
When gravity pull the drone mass down towards the ground, we dey call am weight. The thrust wey the props dey produce go balance the drone with force of gravity, so e go float for air if the thrust from all the 4 props na the same with the weight of the drone. We dey call that balancing equilibrium. We fit call the movement wey the drone dey do hover, but e no mean say the drone no dey go front or back. E just mean say the drone dey fly for one particular height or level.
To confirm wetin we just talk, you fit bend the drone for one side, dey move am and e still no go up or down because the force wey dey lift am, that is the thrust, still dey equal to the weight of the drone. We go cover how dem dey take calculate lifting force for the next video.
But make una wait, plenty still dey.
E still no mean say the motor dey produce the same amount of thrust. E depend on the structural dynamics of the frame of the drone.
We go talk about structural dynamics soon, but make we first understand how we go take modulate or control our thrust.
When we move the left stick of the mode 2 transmitter left and right, e go apply the same thrust to all the motors and dem design am to increase and decrease the level of height or altitude wey the drone dey fly.
Then flight controller go correct any minor error for the thrust wey the 4 props dey produce. E go do am by controlling the speed wey each motor dey use rotate to keep the drone stable.
Structural dynamics get very big effect on the way your quads, that is 4 props, go behave.
Make you notice how the 2 left hands of this quad long past the right hand. The left motor get mechanical advantage past the right one, so the right motor go do more work past the left ones.
Wetin e mean be say our physics model never complete. We suppose consider the structural dynamics of this drone.
We go need understand wetin dem dey call moments of the arm. The moment of the arm dey consider the thrust wey the prop dey produce and the mechanical advantage wey the arm dey produce due to how long the arm dey.
Dem dey calculate the moment of each arm by multiplying or timesing the thrust wey the propeller dey produce by how long the arm take be.
So to hover or maintain constant height or altitude without slant movement no be matter of equilibrium of thrust, but na matter of equilibrium of arm moments. We go fit consider moments in simple positive or negative values like rotational force, because say the quad's equilibrium dey in 3 dimensions.
When we dey talk about thrust, we go think am like say e dey try move for straight line on the x-axis, that is slant direction. Each of the arm moments dey apply e own force towards the center of the mass of the angle of torque on top the z-axis, and e dey start from the center of the quad frame.
So we need to dey think of arms like say e dey extend into 4 quadrants or 4 parts as per x and y axis. Like this, we go see say all the x-axis wey dey negative go cancel and the x-axis wey dey positive, so that everything go balance for equilibrium.
If we wan make our drone move, na more say we break this equilibrium, and the way to break am na to make the negative x values overpower the positive x values, as we fit turn am around, make positive x overpower negative x to move our drone right or left. Another way again na to make the positive y values overpower the negative y values to push am front or back.
The stick wey dey for the right of the mode 2 transmitter dey increase the throttle of the 2 motors for one side of the drone. Make we call am the negative x motors for one side and the positive x motors for the other side. Now wetin dey make the drone move for one kind slant position?
If we move the right stick up, e go increase the throttle for the motors wey dey the back of the drone. Make we call them the negative y motors. The negative y motors go overpower the positive y motors, and e go cause make the drone lean and move forward. If we pull the right stick down, it will cause the positive y motors to overpower the negative y motors, and therefore make the drone lean back and move backwards.
So make we put everything together. Now the throttle and in general now the up and down axis of the left stick go dey control am. For mode 2, however, na the flight controller go dey modulate the amount of throttle wey e go dey produce in response to the input wey go dey comot from the transmitter controller. For example, if you dey roll to the right, the flight controller go increase the throttle for the left motors M1 and M4, while e go dey decrease the throttle for the left motors M2 and M3 at the same time.
To calculate all the torque wey each motor must produce to make the drone fly in one direction or maneuver, you must sabi the amount of pitch, roll and yaw the way the maneuver go need. So make we talk say rolling right na positive value and rolling left na negative value. Pitching forward na positive value and pitching back na negative value. Then the equations wey dey above go determine the amount of thrust or torque wey each motor go produce.
To dey fly quads na just about how to manipulate equilibrium between forces, structure and gravity.
For the next video, we go talk about how drones dey unstable and how dem get complex dynamics for flights. But if we look the quad flight character well through the eye of the STEM disciplines, e go touchlight the odd machine wey be the quad motor drone.
And make una look out for our practical video wey go tell una method wey go use the science and technology wey we dey talk about for this video to help una build better drone, and e go teach una how to be better pilots for your drone well.
I be Chidera for GUBot Dev, and this na Ayodeji, and we dey remind you make you support open source community today. Make you na click on advert on video wey you na like, donate to the person wey dey contribute video wey you na like, or you fit add your own video so others go fit learn. All of us dey stand on top person shoulder to learn, so make you na go fly.